Welcome back, guys. Day 7 problems. So let's first look at the first one here. This is the oxidation of ammonia to form nitrogen dioxide. Water is formed at a rate of 42 molarity per second, basically. So we have a reaction. So the oxidation of ammonia, so NH3 gas plus O2 gas, giving us water, and NO2 and water. Alright, so balancing them, we have 4, 7, 4, and 6. Alright, so the rate of, so this is a relative rate problem. So that's where the overall rate is equal to, for negative 1 over 4, the change in concentration of ammonia, change in time, alright, equals negative 1/7 change O2, change in time, equals positive 1 over 4 change in NO2 over the change of time, and that equals positive 1 over 6. Right, those are the coefficients in pink, right? Change in concentration of H2O, change in time, over the change in time, delta T. Alright, so what do we know? We know that the rate of O2 being consumed is, right? Oh no, the water is formed. We know the water is formed. We're looking for O2. We're looking at water is formed. So water is formed at a rate of 42. So this is 42 molarity per second. So that's what that number is. Right? Because all those are numbers, right? And so that's what that number is. So mathematically, how this works out, right, is that the rate of the reaction equals 1/6 times 42. Right? So that means 42 divided by 6 would be what? 7? So the rate of the reaction is 7 molarity per second overall. Right? That's all that means, right? So rate equals 1/6 times the change in concentration of water, change in time. So that's how we come up with 7. So now for this number right here, because we're going to get ammonia, we're going to get NO2 as well. It's going to be the same. I'm going to get O2 and O2, but for ammonia, right, negative 1, so 7. So X times negative 1/4 is 7, right? So that would be, negative 28 molarity per second, because negative 28 times negative 1/4 is 7. Oxygen would be negative 49 molarity per second, right? Because negative 49 times, right, because that's the number right there, negative 49 times negative 1 over 7 is 7. N2O, right, this one, this number right here is 4. So that would be what? Positive 28 molarity per second. So that's the relative rates at that time. And that's all relative rates are. Okay? Now, the next, we've already done this one in the lecture, so we're going to skip that. Consider the reaction N2O going to N2 and O2. express the rate of reaction in terms of the change in concentration of each of the reactants and products. That's relative rate. So for A here, the rate of my reaction would equal -1/2 change in concentration at N2O, nitrous oxide, all over the change in time, equals +1/2 change in concentration at N2, change in time, equals 1/1 times the change in concentration at O2, change in time. So there's A. So in B, I have 15 seconds, 15.0 seconds, 3 sig figs, right? 0.015 moles is produced in reaction with the volume of 0.5 liters. So I have 0.015 moles all over 0.5 liters, right? What's the average rate of the reaction during this time? So I'm going to find my molarity. Right, I got 0.015 divided by 0.5, and that gives me 0.03 molar. So this is 0.03 molarity in 15.0 seconds, which is, if I divide that by 15, that gives me 0.002 molarity per second. All right, and so now, because O2 has a coefficient of 1, the rate is the same as the rate of O2, because it's a 1, coefficient's 1. So the average rate is 0.002 molarity per second, or 2. Really, I have 2 sig figs, 2.0 times 10 to the -3rd molarity per second. So predict, now we have to predict for C. We have to predict this guy, which is right here. Alright. So what do we know? I know that the rate is 2.0 times 10 to the -3rd molarity per second equals -1/2 my rate. Alright. So times by negative, or times both sides by -2, I get the rate of, or the change in concentration at N2O with the change in time, equal to, what is that, 4.0 times 10, -4.0 times 10 to the -3 molarity per second. And there we go. So there's that one. Next on our sheet, for the reaction of A plus 1/2 B going to C, right, determine the expression for the rate of the reaction in terms of the change in concentration of each reactant and product. That would be relative rates. Alright, so rate equals, since it's a balanced reaction, because we don't know, it's got coefficients, 1/1, the change in concentration of A, change in time, right? Now, it's 1/2, right? It's right. So what do we do? It's actually, and that's negative. It's equals -2/1 times the change in concentration of B, change in time, right? Because how does that math work? It's it's technically 1/1/2, so it's 2. Okay, plus equals 1/2 times the change in concentration of C over the change in time. All right, so there's our relative rates. Wonderful. Okay, so when C is that 0.025 molarity per second. Right? That's what C is. How fast is B and A? How fast is A and B going? I always recommend going to the rate. Okay, so I'm going to do 1/2 of 0.025 molarity per second equals my rate. So my rate happens to be 0.0125 molarity per second. Alright, so now that means for A, It's the same. It's just negative. Negative 0.0125 molarity per second. Now, B, the rate of B, a little different. So let's do B. I'm going to take 0.0125 molarity per second. And I recommend writing this out. Equals negative 2x. Right? Because that's going to be my x right there. So, what do we get here? Times both sides by negative 2, or divide both sides by negative 2, right? Negative 2, divide negative 2. It looks like I get negative 0.00625. That's a 0. And there's my, or sig fig wise, I guess we would have 0.013 molarity per second, negative 0.013 molarity per second, negative 0.0063 molarity per second. But there we go. There's our, problem was that 28. 30. 30 is the same thing, relative rates. All right, you can see how their rate and then all the relative rates. So what I would recommend is that for 30, I have, now these are reactants, so negative 1/8, the change in concentration of H2S, change in time, equals negative 1/4. The change in concentration of O2, change in time, equals 1/8. Change in concentration of H2O, delta T, and I would have equals 1/1, change in concentration of S8, delta T, equals the rate. Now I know what H2S is, so this guy right here, right, that number is negative 0.080 molarity per second. Right? So if I know that, I can take negative 1/8 multiply negative 0.080. That would be 0.01, isn't it? 0.010 molarity per second. Alright, so if I know that, now we can do the rest of them. Right, I can do the rest of them. Pretty straightforward. So, what are the rest of them? Well, S8 is pretty easy, 0.0, well, let's put it up here in the chart. This is 0.010 molarity per second. This is 0.010 molarity per second. Alright, times, so this would be, water would be the same as H2S, except it's positive, plus 0.080 molarity per second. And O2 would be half that, 0.040 molarity per second. And so again, that's relative rates. Let's see, now we have initial rates. We got iodide ion reacts with hypochlorite ion, right? The active ingredient in chlorine bleaches in the following way, right? And it gives you I minus, replaces Cl minus with oxygen. We'll switch dance partner there, or single replacement. This rapid reaction gives the following data. Gives you 3 lines. So we'll do experiment 1 in green, experiment 2 in blue, and experiment 3 in pink. Alright, so what do we have? Well, if I look here, the difference between 1 and 2, green and blue, there's no change in I minus. What happens here? Well, that's at times 2, right? 1.5 to 3. It's a double. Well, what happens there? So, it's just the same exponent. You just take 2.72 and divide it by 1.36, which, if you look at that, it happens to be 2. Right? So, if I double the concentration of OCl minus, hypochlorite, I double my rate. If we go to the rate law, rate equals K times concentration of OCl minus times concentration of R minus. I know now that the exponent of hypochlorite is 1. Alright, so now if we look at experiments 1 and 3, same, times 2, also times 2. Right? So that means it's also 1. So there's my rate law. Alright, now you can go back and do it the long way where you do experiment 1 over 2 or 2 over 1 and put it into this form. You can more than welcome to do that. But it's much faster to do it by inspection. So that's A. There's A right there. Boom. Done. B. Calculate the rate constant. Doesn't matter which one we'll use. I'll use green. So 1.36 times 10 to negative 4 equals K times 1.5 times 10 to negative third to the first, 1.5 times 10 to negative third to the first. So in my calculator, 1.36 times 10 to negative 4 divide 1.5 times 10 to negative third, and I have to do that twice. However you want to input that in your calculator. So for K, I get 60. And 2 sig figs is right, 60.44444, so 60 units. Well, that's going to be 1 over molarity times second, right? Because if this is molarity, right? And this is molarity per second, I need to have the second, right? And that's it. Now, C says calculate the rate when it gives me new concentrations. So for C, we got the rate is K, which is 60, 1 over molarity times second, times OCl minus 2.0 times 10 to the negative third molar, times 5.0 times 10 to the negative 4 molar. And right, one of the molars cancel, so molarity per second works out. So that rate would be 60 times 2 times 10 to the negative third times 5 times 10 to the negative 4. 6 times 10 to the negative fifth is what I get. So 6.0 times 10 to the negative fifth molarity per second. And that's what I get for number, whatever number that is, I don't know the number. Alright, the next one on this video is another method of initial rates. And again, I got experiment 1, I'll do in green, experiment 2, do in blue, and experiment 3, I'll do in pink. Alright, so again, the rate law will be in the form rate is K times concentration of ClO2, chlorine dioxide, and hydroxide. And we don't know, right, what P and Q are, or M and N, or R and S, X and Y. It does not matter what they are, right? We'll just pick two variables. Alright, so let's see here. If you want to do it the long way or the short way, I don't care. Alright? So if I try to do the shortcut, right, that, right, is a times 3. Right? 2 to 3. That's the same. Right? So 0.06 divided by 0.02 is 3 times. What happens here? Well, that's 0.0248 divided by 0.00276. And that gives me 9 times, basically. Alright? So that gives me 3 to x, or excuse me, in this case 3 to p, equals 9. So p is going to be 2, right? That's what's going to happen. So p will be 2. And then if we look at, do orange here, that's the same. Alright, going down. That is 3 times, and that is what? So, also 3 times. Alright? So, 3 to what power is 3? 1. So it looks like my rate law would be rate equals K times concentration ClO2 squared to OH minus. So let's recap. Let's do it the long way once. Let's just do it the long way one time. So again, I'll do experiments 1 and 2. So experiment 1, the rate is 0.0248 molarity per second. And that's, well, I don't want to do those parentheses, sorry. K, 0.060 and 0.030. And then experiment 2 is 0.00267 molarity per second, K, 0.020 and 0.030. All right. And we had P and Q there. And so if we do this math, I get 9 equals 1 times 3 to the P power times 1 to the Q power. Alright, which then simplifies to 9 equals 3 to the P power, P equals 3. So that's how we do it the long way. Either way works for me. Alright, so now calculate the rate constant with the proper units. Doesn't matter what we use. I'll use the green. Why not? 0.0248 molarity per second equals K times 0.060 molar. That's a horrible 0.60 molar squared and 0.030 molar. Alright, so K looks like it is 0.0248 divided by 0.06 squared divided by 0.03. 229, so 230. Alright, yeah, 230. Let's go with 230, 1 over molarity squared times second, because there's molarity cubed here, and that'll work out for me very well. Alright, and then C, calculate the rate constant at this point, or the rate with this point. So, going back to my rate law, for C, I have the rate equals K, which is 230, 1 over molarity times seconds, times CO2O is 0.100 molar squared, and 0.050 molar. Alright, so my rate equals 30 times 0.1 squared times 0.05. I get 150.115 molarity per second. Well, there you go. There's the method of initial rates. There's relative rates, and so hopefully that makes sense. Again, get up with me if you have any questions, and take care.